Hello, I Bhushan Tiwari welcome you all. Today I am going to present a beautiful question picked up from Indian National Physics Olympiad. I have made some small changes in the language of the question so as to make it more unambiguous, and I have given it a form of MCQ so that it becomes more suitable for JEE Advanced aspirants. Here is the question. Please read the question carefully and give it a try on your own. You will enjoy thinking about the question. Here is the question. I will read it for you. A student performed an experiment to determine the acceleration due to gravity using a simple pendulum which has a spherical bob hung with a long string. She varied the length of the string is L, and measured the period of oscillation T every time. We are told that the instruments were accurate and the measurement were properly made. She calculated the value of G from each measurement as shown in the table below. Each one of the measurements had yielded a value smaller than the true value. Next, she plotted a graph between T square and L from the same data and obtained the value of G from the slope of the graph. Now, this is the table recorded by the student. These are various values of L, and these are recorded values of time period. Based on these pair of values, every time acceleration due to gravity was calculated, and throughout the observation, you can see that value of G was significantly less than its true value, which is 981 centimeter per second square. Please read this as centimeter per second square. Now, I have modified this question to give it a form of MCQ, and here are your options. Option A, the value of G so obtained will be noticeably less than the true value 981 centimeter per second square. The value of G obtained by the experimental method described will be significantly less than the true value. That is first option. The second option is the value of G obtained will be close to the true value with error not more than the limitations of the experimental apparatus and precision of the measurement. That means the kind of instruments that have been used for measurement, of course, depending on them, there will be some propagation of error. But apart from that, there will be no major significant error as far as calculated value of G is concerned. That is your second option. I'm sorry, it was not displayed here. Now it is being displayed. The third option, the value of G so obtained will be not noticeably higher than the true value of acceleration due to gravity. And the last option says the graph will pass through the origin. If you have missed some part of the question and you want the entire question in one frame, then for a moment I am getting out of the frame and you can have the question and the entire question in one single frame. Just because the font size will become smaller, I presented the question in 2 slides, but if you want it in one complete slide, you can take the snap, screenshot, read it and give it a try. So before I actually explain the question, let me ask you one more question. Why do you think that the readings are actually less than true value? They are consistently less than true value. Not even once it is higher than the true value. So there seems to be some systematic error. If there is a mistake in the procedure of experiment, if there is some environmental condition which is affecting the outcome of the experiment, all your measurements can go one way from the true value. And this is what seems to be happening here. Can you spot that mistake? It may be deliberate also, but right now let me call it as mistake. Can you spot that mistake? If you can, then you will get the answer right. When you measure small g using the formula of time period of simple pendulum, the length of the pendulum is nothing but length of the string plus radius of the bob. Do you remember that? It is distance between point of suspension and center of mass of the bob. In this experiment, it is written in the question that it is a spherical bob, but nowhere the experimenter has measured the radius of the bob. She has only measured the length of the string. So this L is not actually the true length of the pendulum, and that is what is causing all the readings to go, and that is what is causing all the readings to be on one side of the true value. If you have got it, you can still pause the video and give it a try. The question, what is the correct answer? Here I am proceeding with my explanation. The usual formula for acceleration due to gravity using the simple pendulum is like this only. This T is equal to 2 pi under root L by G, which has been put into this form. You measure L, you measure T, and you calculate the value of G. If you look at it carefully, there is nothing but T square is proportional to L. 4 pi square by G is a constant. If you are performing experiment inside this room, value of G is constant, and therefore T square is proportional to L. If you plot a graph of T square versus L, it will be a straight line passing through the origin, right? But as I have pointed out, that a deliberate or maybe really a mistake was made, and the length of the pendulum was not taken appropriately. So actual length of the pendulum will be L plus R, where R stands for radius of the bob. If you do that correction here, then acceleration due to gravity will be given by this, and in this case T square can be written in this form. This A is the same constant, as you can see, 4 pi square by G, and then there will be another constant B. So if this time you plot a graph of T square versus L, which was done by the experimenter, this graph will still be a straight line, but it will not pass through the origin. It will have a positive y-intercept. Can you see that? I will show you the graph. The graph will appear somewhat like this. If you extend it, it will pass through a point which is not exactly the origin, because y is equal to mx plus c. That is the form of this equation right now. But in any case, whether you take this case or this case, the slope of the graph remains same. Slope of the graph is A. So what the experimenter did, she didn't bother to measure the R, or maybe she forgot to measure the R, but somehow after the mistake was committed, she found a way to still get the value of G. She found that if a plot of T square versus L is made, then the slope of the graph will remain same. It is not changing, and the slope of the graph is 4 pi square by G. So you can plot all your experimental data over here, have a best fitting straight line, measure the slope of the line, and that slope is 4 pi square by G. So if you know the slope, you know the value of G. In the actual question, this graph was actually given to be like this. If you look at it carefully, it was not exactly passing through the origin. It was passing slightly above the origin. I hope you enjoyed this question, and now you will have to decide whether the experimenter made a deliberate mistake